So you've got a vessel that is aground in a channel with a bridge laying on top of it. This is unprecedented for this region. And our team has really come together, not just the United States Army Corps of Engineers team, but we've partnered with the United States Navy with our salvage experts out of the Supervisor of Salvage. And we've also partnered with the Coast Guard. So you've got this DoD team that now is bolstered by all the state and federal partners and agencies that are coming to support, particularly the state of Maryland, just from the governor on down. It's been an incredible team effort. We were blessed to have really clear prioritization from Governor Wes Moore out of Maryland, where the overarching top priority is recovering of the missing persons. And then we've got the priority to clear the channel. The state has additional priorities of taking care of its people and rebuilding the bridge, but within the clearing of the channel, we have this massive operation with a unified command where our top priority is clearing the channel, the second priority is refloating the vessel, and then our third priority is clearing the wreckage outside the channel. This requires the integration of 3 salvage efforts. We've got the contractor, the salvage contractor, Don John Marine, that is clearing the center main shipping channel, the 50-foot deep channel. You've got the salver for the vessel, Resolve Marine, that is working that salvage operation. Then you've got Skanska working for the state. Those 3 efforts need to be integrated. And the efforts are prioritized based on what we need to do for the city of Baltimore to get this port up and running, restoring those jobs and all the businesses that support the port. So as we were developing the plan and prioritizing opening that limited access channel, it's a 35-foot deep, 280-foot wide channel that will allow some traffic to come through, about 70 to 80% of the port's traffic to come through. And as that's being prioritized, we were working on the far side. In the meantime, we're still working to remove that massive span on the vessel. Initially, we thought we would cut off that portion that was sitting on top of the vessel and then lower the remainder of that big span down to the floor, the riverbed. And we realized that that was not going to be safe and it had too much uncertainty. So while the priority was to open the channel, we took advantage of that, adapted the plan. So now we're going to be opening the limited access channel by the end of April. And then we're still engineering how we're going to cut away and drop that 5,000 ton span off of the vessel. So the Unified Command has presented a very well thought out recommended plan that is continually refined and improved by the best salvage experts that we have in our country. The wreckage itself is cantilevered, mangled, and collapsed at the bottom of the riverbed. And understanding how the material is set and laying is important. Understanding if those members are in compression or tension is really critical to how the wreckage will be cut, rigged, and lifted. So the way I've explained it is if you've got a spring that's in tension being pulled, but it looks just fine and stable, and then you cut it, you could have such a reaction of almost like a snap and an irregularity that could be very hazardous to the equipment, the cranes, and the operators that are there. So the divers are very critical to understanding whether or not those connections are in fact present. The divers are going into very low visibility, very murky water. It's like driving through a heavy snowstorm with your high beams on. And they have very limited visibility to about 1 foot to 2 feet in front of them if they're lucky. So they're being guided by operators of 3D sonar imagery that are guiding their hands underwater to reach in and feel for the connections and understand how the material is laying and how the wreckage is on the bottom of the riverbed. I think when we got to see really the power of the Coda Octopus 3D side scan sonar, for me that was incredible to be able to see a 3D image under the water and to understand what it all takes to be able to engineer these lifts and how they're designed and the center of gravity is calculated and how the pre-rigging, then the rigging is executed all the way to the crane operator and every safety measure that has to go into that to even just the rigging.
Right.
We all see the steel coming out of the water, but the engineering that had to go into ensuring that even just the pre-rigging before the rigging and the lifting takes place, it's not just about the engineering. The work that goes into all of that, the mechanical and then the brain power behind it's amazing.